Hi, my name is Dylan. Today my partner Jordan and I will be taking you through a tutorial on clustering.
So first of all, what is clustering? Clustering is a practice where data will be divided into groups of things that are close together in terms of distance. There are different methods of measuring this distance, including Euclidean distance, city block distance, also known as Manhattan distance, and cosine distance. Euclidean distance is a direct measurement between 2 points and is an expression of the phrase, "as the crow flies." This is the shortest distance between the 2 points.
City block distance involves taking a squared off path from point A to point B. This is also known as the Manhattan model, appropriately named because the path that is measured reflects the way someone would navigate through city streets. City block distance can be quantified as the sum of differences along each dimension. Cosine distance involves measuring the angle from the origin of the graph. The smaller the angle is, the closer the 2 points will be together.
Now that we have covered the different methods to measure distance, we will now discuss the different types of clusters. There are several types of clustering, but we will be focusing on k-mean clustering and hierarchical clustering. K-mean clustering is the simplest type of clustering and begins by picking random points to be the centroids of the clusters. Every data point is assigned to a cluster based on whatever centroid it is closest to. As you add more data points to this cluster, the centroid shifts in position to be at the center of the data. You continuously repeat these steps until you have iterated enough.
This is an example of k-means clustering. In k-means clustering, you will start with a set of data points, such as what is on the screen now. At this step, you split the clusters up into the points that are closest to one another, as indicated by the different color of dots in this. The diamonds on the screen represent centroids. The arrows on the screen indicate moving the centroids to the center of each cluster.
We are now going to show you an example of hierarchical clustering. To begin, you'll be given a series of dots that represent data in a diagram. First, you need to identify the 2 dots that are the closest together. In this case, it's R1 and B. So then you would combine the 2 since you average the distance, and you would see this in our next diagram where the label is now R1 and B, and it's half the distance between the first 2 dots. You would show this in a diagram by connecting the dots and saying R1 and B are now together. Then you identify the next 2 dots that are closest together. In this case, it's R1B and R2. So as you can see in our next diagram, we combine them by showing R1, B1, or B and R2 as the label. You would also need to note that since R1 and B have 2 dots already connected together, they have twice as much weight as R2 and therefore are a little bit closer to the R1B original location than the original R2 location. You can now combine these as well by drawing another part of this diagram and saying R2, because now R2 is connected to the new R1B dot. Lastly, you identify the last 2 dots that are closest together. In this case, it's R1, B, R2, and G. Those are the only dots that are left. As we said before, R1, B, and R2 now have 3 points that are connected together, so they have 3 times as much weight as this G dot up here, and therefore will be 3/4 closer to the original position here than the G dot there, which is noted in this last diagram here. Now the dot has a label R1, B, R2, and G, and represents an average of all of the dots that we originally had on the diagram. You can also finish this diagram over here by drawing another line here and saying G is now connected to all of these dots which have been averaged together. This is a great example of hierarchical clustering.